Hello, IPXers. Good morning, good afternoon, good evening, wherever you are. You are again in the world famous, as I call them, IPX studios. They're not really a studio, but that's what we call them. Anyway, this morning, this afternoon, this evening, we're going to talk to Xavier Dupont from a company called SG Wireless. Now, we're going to talk about IoT. Everybody talks about IoT. You know that we talk about disruptive technology in IoT every day, and we introduce new companies, new technologies, new ways of doing things. However, this morning, Xavier is got huge amounts of history and legacy and experience in IoT, and he's going to talk us through a lecture that he does to students about the definition of IoT, the trends in IoT, what's going in IoT, and when you start a project, maybe what the things that you should be thinking about. So we thought it'd be lovely to have a chat with him. He's calling and talking to us from France. So Xavier, why don't you introduce yourself to our community, tell you about yourself, and then tell us all about how you see today's IoT, which lots of talk in the last month about the failure of IoT, how IoT hasn't lived up to the expectations of what we thought it was going to. I'm not sure that's true. I just think some of the wild and weird and wonderful ideas that people thought IoT was going to be used hasn't come to fruition. But to suggest that IoT hasn't changed our world, I think wouldn't be exactly what's been going on. So anyway, I really am going to stop talking now. Xavier, tell us all about yourself and tell us all about how you see the world of IoT today.
All right, guys. So first, let me really thank you for this invitation. It's always a pleasure to share my humble experience on my journey in IoT, which has been 20 years of my life. I really didn't know what I was doing when I was starting my journey, and maybe it was a good thing. But yes, I could learn a lot. So just a few words about myself without being spending too much time. So I'm Xavier Dupont. So you can hear from my accent, I'm from France. I lived 20 years outside of France. I lived in China, I lived in Vietnam, in India, and 15 years in Hong Kong. I was running a company which was building IoT boxes, which I sold in July 2019. We were number 3 manufacturer in the world for this IoT gateway. Then I stayed with the company which acquired me. And more recently, I joined a very dynamic and great company, which is very close to my heart, which is called Seasons Group, SG for in short, which is a company which is providing two things: services and products. Services in the sense of designing and manufacturing wireless device, boxes, electronic PCB and components, but also products which I call the building blocks in IoT, which will help and facilitate the life of engineers, which today have to face lots of difficulties. You mentioned something, Guy, which was very interesting about the failure of IoT, and there is a lot to say about it. I generally say start my pitch, which is a little bit of a sad pitch, that maybe my French origin, which is about that 70 to 80% of the
You've already said on this call.
Yes.
You've already said on this call that you're humble and you're sad. I don't think either of those things are true. Anyway, keep going.
I keep smiling, you see. So the body language is still okay, right?
Your French charm is shining through and denying both of those statements. But carry on, please.
No, so one of the things I mentioned about IoT when I start is that 70 to 80% of the IoT project, they don't go beyond proof of concept. It's a very sad statistic, but in a way, it is true. It's what I've seen in my life for 20 years. We've been going after lots of customers which had great ideas, new concepts. They wanted to change the world with technology. But ultimately, you start the project and somewhere the project fails. And I've seen it ongoing, right. Scratching my head. What's going on? So this statistic comes from McKinsey. It's not me who took it out. There is a very interesting article and some readings about the why and the how. I won't be able to go through all of this during this interview, but I really invite you guys to look at it. But in short, to make it
Right.
short, I think lots of expectation was set in IoT. Lots of buzz, a bit like whenever a new technology or something new comes, everybody has expectation to the roof, then back to reality, and then we can start to build up again more realistically on what we can effectively do with the technology. So the lecture I gave
Right.
yesterday.
Can I just
Sorry, go ahead.
can I just ask you one question though?
Sure.
You know, we've probably been working in the modern world of electronics. If you take, you know, the introduction of microcontrollers back in the late 90s,
Yes.
as things moved over from electrical systems to electronic systems,
Right.
and the internet came along and mobile phones came along, and then, you know, industrial automation came along. And then we've gradually been making our way through that progress to where today we're now talking about AI and how that's affecting the world. Is it not true, though? Is it not true that probably all electronics projects, 80% of electronics, if you're working on disruptive things, if you're trying to change the world, is it probably not true that at least 80%? I mean, if you're working, and I will use the word on the edge, not as in the edge,
Yeah.
as in the edge computing, but if you're living on the edge of changing the world and technology, is 70 or 80% failure? Is that true failure? Isn't that just the very nature of experimentation and you know, evolution?
That's true. And whenever something is new and actually you try to play a little bit at early stage, there must be this kind of failure, trial and error, and keep trying. Let's say what was challenging for IoT, I believe, is in some sense we started with existing technology like cellular, and the cellular technology was not meant to send critical data. And on another hand, it was a little bit two different world, the world of technology which meets different industry. One of the successful case in IoT is the metering, in my view. Metering has been deployed in so many countries.
Absolutely.
But it's really two different worlds. The world of traditional industry, the world of technology, which meets, and they need to speak the same language. They need to agree on the practice. They need to agree on the expectation. And if you look at, for example, a meter has to be have a warranty of 10 to 15 years. Generally, a cellular module change technology every 2 to 3 years. How do you reconcile these two? So it's a challenge. So there was really, let's say, and it took decades to really came to a point where there is a kind of an agreement between the technology provider and the industry provider to say, okay, we start to understand your concern. We need to apply your stuff into our stuff because we need it, because we see some major trend. We talk about digital transformation now, but how do you make digital transformation without connecting? And how do you connect securely a car without creating an accident? How do you connect a gas sensor, which needs to work 99.9999%, otherwise you have an explosion? These kind of things.
So if you know, you're talking about, and we're having a good sound chat about, you know, where we are with IoT. So in your experience today, you just use the experience of the meters. We're here now sat in late 2024. We have, you know, the idea of AI coming into our systems. We've had sensors now with us, the millions of sensors that are available, taking in data every day. We have more efficient processing that we've already had. And then we have the process by which we take that data and we get that data into the cloud or wherever you want it to go.
Yep.
So if IoT has been a great success, which I personally think obviously it has been, it's not true that it's failed. Where would you say today are the standout examples of where IoT has come to fruition and is bringing value to the world?
Yeah, in terms of application and market, you mean, Guy, right?
Yes.
Yeah.
In terms of where we've taken those component parts. The whole idea is taking data, connect a machine, efficiently understand that data, and then send that data to the point that you want to process it and understand it, make use of it, whether that's to, in the metering case, take the amount of electricity that's being used or how much gas is being used, and then have some sort of way of processing that and turning that into a business model. Where have you seen that now today, where you go, IoT is implemented, it's in the field, it's successful, and it's a business model, and it works, and it will continue to work?
For sure, yes. And there is two vertical market. We used to talk about verticals. So there was multiple that IoT was addressing. The two verticals, which I think, I'm sure are successful, and because there is millions of deployment happening today, is the metering and the energy management and metering, big area, and now the technology is mature,
Right.
well integrated, well understood by the meter manufacturer and the ecosystem. I relate it to Industry 4.0 also, metering, energy, and industry. They are the two areas where even the concept of Industry 4.0 was just created using IoT to say from automation, Industry 3.0, we move to Industry 4.0, which means we connect and we have a direct interaction with the machine to take actual decision real time from a human or from an AI, which is what's coming. So this is clearly successful,
Yeah.
and you can see it from the market makers, the Schneider Electric. Yep.
So that's very good. So we have those two examples: energy and industrial 4.0. So what does today's design engineers learn? So the ones who are going to fail 80% of the time, according to McKinsey, 80% of IoT projects fail. However, we have these two really successful now legacy. You could almost describe them as legacy because they've been in operation for 15, 20 years. What are the things that I'm going into other areas? So let's say maybe it's medical. Let's say it's sensing, out in the field somewhere where people are inventing absolutely, astonishing ways of using this concept of IoT.
Mm-hmm.
What things should they take from that's my platform that works? Those are the things that we know that can work. So I can take those and I can use those so that I can go and invent things so that my failure rate is not 80%, but it's closer to 50%. What are the things that they can take from that legacy in history that they know, right, if I implement that, I know I've got a good platform, good foundation, and now I can go and invent new things.
Yeah. No, that's so. And this discussion was exactly the starting point that I had with the Seasons Group, with Carl, which is the CEO of the company. And we thought, okay, how do we improve the success rate? And that's really the vision of SG, Carl, and myself. It's really to help our customers and help anybody who wants to be successful in IoT. And I think the number one thing you need to do is to remove the complexity for the engineers. For many years, you meet a company,
right,
and the discussion is like, okay, shall I use cellular, Bluetooth, Wi-Fi? I heard there is this new protocol coming. My engineer loves it, etc. No. So first, stop. Okay, technology is great, but it's really about the business case. So the way we approach the market is, number one, we provide both service and products, but on the first step is to try to frame with the customer, like, what's your value proposition? Simple business stuff, but you would be surprised on the kind of answers I receive. What's your return on investment? You want to deploy an IoT product, these things, how you will make money with it? Because in the end, if you go, IoT is a concept which applies to many business. And the three things that the customers are looking for is reducing operational costs, to be clear, improving your customer satisfaction by having insight real time, and changing business model from products to service, recurring, SaaS, etc. Customer companies which needs to reinvent themselves. So the first three things that I am looking with a customer is how do I help him to achieve this target? What he has in mind, and then after that, we start to talk technology. Use case. Okay, you are in the middle of the
Right.
Rockies. You want to monitor the snowfall, and you need to have a robust device with little coverage. You might need to use LoRa technology for short range. You need the hub in cellular, and then you need to have water protection, blah, blah, blah. So the two areas where I see companies failing is number one is defining clearly the goals and framing properly the project in a way that it's visible in a company and that everybody understand why you want to do it and how we'll make money with these things. Technology is great, but it's how we make money.
Right.
Number two is scaling.
So
Yeah, go ahead. Yeah.
So so just so that we're clear, because I think this is very interesting. So just so we're absolutely clear, somebody has an idea. They need to step away from that idea. They need to step away from the problem that they're going to solve technologically, and they have to start at the business case. They have to say those three questions that you gave there, or answers to those three questions. That's the key point. Can I add value? Can I create a business model? And can I give customers improvement in their world, whatever that is?
Right.
So it's always going to start from the idea, of course. Always going to start from the idea. But you say, step back from the idea and work out whether it's actually got a financial model sitting behind it. Okay, good. And then you get back to the idea. So let's go from there, because that's, I think, which is where you're going to next.
The next step is once we have an idea, we put together a spec. Then fast prototyping. We talked a lot about MVPs recently and design thinking, lots of new trends into the design mindset and innovation. Great. I love it. We have a 90 days proof of concept. So what we try to do is within 90 days, we give ready to use products for our customer, because we believe like the sooner he has his dream product or his MVP dream product in his hand, the faster the engineers can test and he can start to, let's say, assess his assumption. I thought it was going to do this.
Right.
It's doing this. Okay, I need to review the way I was thinking the system was working. And by iteration, not so many, then you come to something which is close to mass production.
Right. How often do you think people get that hit that 90-day point?
Generally, the way when we give, so we have this small kit, which is, we call it the F1. It's a multi-technology modules which provides cellular communication in LTE-CATM. It provides LoRa, Wi-Fi, BLE. So it's a multi-technology modules with MicroPython. So in MicroPython, there is a huge community behind. It's a great, very easy for an engineers to get started. And we made it zero-touch provisioning on this kit. So now you just put it on the USB and you can start to write your apps. So that's one of the key to achieve 90 days.
So, yeah. No, sorry. No, good answer, because this is all about, we are all about disruptive technology. We want to introduce technology to companies, and we have no problem with you showing us your platform that will help you, a design engineer, get to 90 days. No problem with that at all. That's what we want to do.
Thank you, guys.
But my question was, how many people fail to get to the 90-day? I'm asking the question of, in reality, we want this IoT to come to fruition. In reality, do people actually end up spending 6 months, end up spending 18 months, and actually not getting a prototype? And of course, then maybe somebody else has done it, or the market's moved on, or the business model changed. How many in reality, if you set hard and fast rules, which says we've created a business model, we created a business reason for this. Now we need to create it to see whether we can actually make it. In reality, with your experience, how many people hit the 90-day? And the reason why I'm asking that is maybe the 90-day failure is behind that 80% failure. So I'm just trying to get I'm just trying to help. Helping our community to understand what are the points by which they sort of go, we're not on track here. So you've talked about business model, then you've gone, it's important to get a prototype done. And then you quite rightly and fairly promote your platform. That's great. We'll show that on the video. Absolutely. But in reality, is the slowness to get the prototype an issue in the world of IoT?
Big one, very big one. And that's why we came up with this. So the way I approach it, let's say what I've seen with our customer in the past, and with even when after I got acquired, was the 90 days was more between 6 months and 1 year, which is a big one of the main reasons why a project would be killed. Because if you take too much time to do the first protos, people stop to believe into the project itself.
Yeah. So you really endorse and say to people, have absolute focus and discipline. Would you go as far as to say, if you can't see a vision to get to this prototype at 90 days, stop, go back to your business model and say, what have I got wrong there that's taking more than 90 days? Or stop, don't start, how do we get to 90 days?
Exactly.
What are the things in your mind? What are the things that actually slow? There must be an engineering technological reason why people are taking longer than that.
Yes.
So, in your experience, what are the things that people focus on that get them beyond the 90 days, and you think that they can speed up on?
Very good point, Guy. And it reminds me so many meetings. Like, unfortunately, because all these things are new, there is real challenges that engineers has to look at and decision on the technology which needs to be taken. Do I use Wi-Fi? Do I use BLE? There is no standard in IoT. So how do I transmit my data? Do I use MQTT? Do I use HTTPS? And then all these triggers, different point of views, opinion, between engineers, ego sometimes, inside of companies, history.
What you mean ego? You mean ego gets in the world? Ego never gets in the world of human beings and creating things. That's just not true. That's just not true.
So what I'm doing now, after having done this and listened and watched all these things, now I'm trying to be a bit blunt to say, hey guys, when I give you this, if you cannot do it within 90 days yourself, come to me. I will do it for you in 90 days. And so we work on the scope of work. You have your samples, then you can focus on your data and what applies to your world. And you don't worry too much about how do you connect, and let us help you to take the risk of the decision on what to use to ensure you are successful, so you get result oriented. IoT, it's about collecting data which did not exist to feed AI, to feed lots of decision making. So let us help you to get that, and avoid the multiple meetings where there will be debates which makes sometimes no sense, because the engineers are new to this field and don't have necessarily all the history of what it takes, for example, to deploy 10,000 devices on the cellular over LTE-M in North America, when you cannot even have in North America a map of the coverage. It does not exist. Nobody published this. So how do you know that when you will be deploying these things in the middle of somewhere, it will work? So if you haven't thought about this, if you don't have the experience or the sad stories or the failures, and learn from it, then you will fail and you will be part of the statistic.
Yeah. So what you're describing there is, the need. The vast majority of IoT developments, obviously, there's clear examples of people like Tesla, for instance, which is a device on wheels, which is an IoT device, where the sensor's being taken in, they've got the communication right, they bring the data in, and that's a successful example of an IoT. In the world today, the world that our community is part of, I'd obviously like to think that all our Tesla engineers are watching this and trying to learn from it. But the reality is, we're talking about 10,000 parts, 100,000 parts, where a new solution has been created. Looking to see how you're taking data, analyze that data, and that get that data to some way into the cloud, so it can be analyzed and reused and people can learn. So what you're actually describing here isn't an idea problem, isn't a talent problem, isn't an ability to be creative, isn't an ability to solve problems and to understand technology. What you're actually describing is a lack of focus and a lack of discipline. And therefore, the more if you follow your model, what focus and discipline will bring is asking those questions literally every day, however big your team is. So let's say, I imagine the average engineering team, even when it's broken down, is no more bigger than 10 or 15 people. Because if it's bigger than that, then it'll be broken up in other design teams doing other things in part of the system. So you're just saying you have to be absolutely rigorous on, have we worked out how this is going to make money and bring value?
Yes.
So once we've done that, then we're going to work out what the product's going to be. And then every day we work towards a ticking clock that says, on the first day, we have 89 days to go. Yeah. And on the second day, Yep, you can work out where this is going. We have 88 days to go. And on the third day, we have 87 days to go. And you have to keep asking the question of, what have we got to do in order to have a prototype on the 90th day? And you believe that if you have that discipline and you ask the right questions, you're going to have to leave your ego at the door. You're going to have to compromise on protocols that you believe were the right protocols before you started the project. But actually, you've got to knock them off if you think that they're going to delay you, and you've got to go in a different direction. Because, and I love the example of the cellular thing in America. You don't even know whether you're going to get. You go, oh, I'm gonna watch wolves in Yellowstone. No, you're not. Yes, I am. No, you're not. However much you think you are, you're not. And it's as simple as that. Because if I'm only using a silly example because I watch Yellowstone and I know that there's wolves in Yellowstone. So it's a silly example, but it makes the point that unless you've thought through the business model and then you've worked out the infrastructure and the logistics, and then you're utterly disciplined, the chances are you're going to end up in that 80% category. Therefore, IoT has failed. Not true.
For sure.
But we can get that figure down. So in reality, is it, if you follow those very simple rules, which are very marvelous, you follow those very simple rules, do you think then statistically we're going to get lower than 50%? Just by doing that? Just do that, and you've given yourself half a chance of being successful.
You give yourself not yet half a chance, but almost, because at least, as you say, you can get your product to Yellowstone and you can start to see how it behaves. And then that's
yes. Okay.
We move generally
good.
by milestone.
Good. All right. So let's then let's. I'm glad you've done that. So we're now in Yellowstone looking at wolves. We've now created a new model called Xavier's model. And Xavier's model's first two steps of Xavier's model are we've discussed. We're now in Yellowstone looking at wolves. Our prototype is doing the work. What's the third Xavier rule?
So the first is to deploy and test your assessment. And then once you get to the point where you start to see what you wanted to see, collect the data that you needed for your business, I would say the odds start to get into your side.
So Xavier's third rule is get your machine doing what you wanted it to do, get the data in, make sure it works. How, at that point, in your experience, how many people get that to happen?
In here, I would say generally the 70 to 80% are killed quite early. As soon as you get the first MVP and the company start to see that there is something real, tangible, like, hey, I'm collecting now this data, then even internally, it's easier to say, hey, look, what I told you. Now I can get to see the wolf in Yellowstone. This is the wolf. His name is
Yep.
whatever, and he's live. He's here. He's with us. And this is like, oh wow, this
Very
is
good.
not a concept. It works. And then internally, the project starts to take off,
Yes.
and the interest of the executive are getting higher because they feel they can do something with it.
Okay, good. So that's the third step, and I think you mentioned that there'd be then 4 rules. Xavier's fourth rule of IoT implementation.
And
so tell me about let's finish off with the fourth rule.
The fourth rule is the most tricky and sneaky, because once you achieve the number 3, you're like, wow.
No!
You think like, okay, job is done. I get to see some data. Cool. Let's put 10,000 on the field, and let's go for it full time. And I've seen it happening, unfortunately, many times. It means the device works in a lab. The device works when you deploy 10 units, and when you put 1,000 units, then you realize that the bridge between engineering and operation, the system validation, industrialization of the system has not been done properly. In every company I've seen, you always have this tension between engineering and operation. Whenever the handover of a project needs to happen, that's where lots of issues happen. And you get to really know the scalability of your system. So now there is digital twins, which can help you to kind of ensure that whatever you deploy is scalable. But so far, lots of people just deploy, and then they get to face thousands of problems, which kills the project.
Right. So, in your going back to the first rule, business development, developing a business model. Sorry, not business development, but developing a business model. You didn't add in scalability. Should you maybe add in? Should you be asking that question? Because of course, if it's not scalable, it's going to fail anyway.
It is.
So should we add in scalability in that first? How are we going to scale, or is that not possible until you've gone through the other first 2 rules?
So part of the part of the definition.
Is it always just a fact of? Is it always just a fact of life that you're not going to know until you've deployed? You've hit your 90 days. You've deployed. You've proved it works, and then you've got scale, and then you've got the engineering versus operations. Is that only ever going to happen at that point, or can you prep for it?
You can definitely prep, and we are talking about IoT, whether it's a failure or not as a market. And I think the last 10 years and 15 years has been a lot to learn about this scalability phase when companies manage successfully deployed millions of units. So some have the recipe, and there is tools. Digital twins, I think, is a great tools to kind of simulate what it looks like. So clearly, part of the definition, generally you cover, I always cover this 4-step: definition, business model, 90 days POC, iteration 1, iteration 2, and then scaling, mass production, testing, validation on the field long enough to ensure that you are ready to deploy million.
Right. So is there a Xavier rule about that to get into to bring operations close to engineering so you can scale?
Yes.
Is there a Xavier timeline rule that says if you don't hit 180 days from prototyping, the project will also lose momentum? Is there another timeline that your experience tells you?
For sure. So timeline, once you have your protos 90 days, then what we do. So again, part of SG, we have 4 factories in the world. We have a factory in Mexico, factory in UK, factory in Malaysia, factory in China. What we do is if the project is with us or when the project comes with us, we generally give ourselves 30 days for testing all the, doing reliability tests, tests on the field also, which helps to ensure and assess that we can go and produce thousands and thousands of products. So if, let's say, the step has been done properly before, and if you get your contract manufacturer close to you, and that's why we have a different setup in the world for multiple reasons, then you increase your chance of being able to scale with less difficulties.
Right. But you didn't put a timeline on that.
Yeah.
Realistically, you can be prototyping all you like. Would you say that after your 90 days, you need to see implementation, scalability, operationally the product working in, I'm just going to say, within a year?
Should be even less than that. In my view...
Should be less than that?
Oh, yes.
Right. Okay.
It has to be. So generally, the production engineering stage in lots of companies is between 4 to 6 months due to components, long lead time of components, and also certification. These are things like you cannot deploy a wireless device if it's not certified. So as soon as you hit the 90 days, you have to put in parallel certification, buying the long lead time item to ensure that you will be ready to scale. And we generally do that in 3 months.
Right. Very good. So we've talked about a lot here, Xavier. I've been a really good conversation about how you should come away from an idea, think about the business model first, sit yourself down in a room and be very disciplined about actually what's the business model for this? How is this actually going to attract customers? How is this actually going to bring benefit to the world? Once you're sure of that, then work out how you get your prototype within 90 days.
Right.
Then once you've done that, deploy in the field, because then you've got to work out whether it actually does all the things that you want it to do. And then if it does that and it's doing that, then be really disciplined to get it into customers' hands and people buying it within 6 months.
Right.
Good. Very good. Right. So the reason why I had Xavier on this call is because he works from a company called SG Wireless, who... Tell us all about them quickly, because it's really important. Give us a potted introduction about what they do, and I think they probably deserve... This has ended up being a Xavier's 5 rules to success, I think. 5 rules to success, which we should probably write down. But let's just say you can do all of that if you partner with SG Wireless and Xavier, and he can take you through the whole of that process with his company. So let's just get I think we're more than happy to do another video on SG Wireless anyway. But just give us I always think these cliches of give us a 2-minute introduction about a company. How can you give it a 2-minute? If I talk about my own company, it takes me about 45 minutes. But maybe that's because I'm not very intelligent and articulate. No. But anyway, Xavier, just tell us quickly about SG Wireless, and then we can say thank you very much for your time today. Tell us just quickly about SG Wireless.
Thank you. Really appreciate. So in few words, and you heard about this 4-step frameworks plus deployment. So SG Wireless has been in the market for 50 years. We've been helping lots of customers to get their product to exist, get their product to life, by manufacturing in one of our 4 sites, Mexico, UK, Malaysia, and China, PCB, but also boxes. What we do now is to have a complete end-to-end approach for IoT, where we will come with this 4-step approach, which I presented earlier, and we will make the product to life. And in one of our production sites, we have for that our secret sauce. Our secret sauce is the small modules, which is called the F1 module, which is a multi-technology modules to avoid the discussion about shall we use LoRaWAN or cellular? Okay, buy one, get the evaluation kit. You put it on your PC. It will be zero-touch provisioning. You will see it on our platform, which is called Control, and the engineers can quickly prototype. That's how you get to the 90 days. That's our secret sauce.
Yeah.
If we let the customer do it. If the customer feels like he needs help, it's like, we are here, we will take you to the end of this journey to be part of the 20%. We will design it for you, and we will manufacture in one of our production sites. So we are end-to-end from concept with let's say, rude French styles to say, hey, you are going into the 80% failures. We will make you successful. Let us help you, right? And
Very good. Very good.
that's for SG. That's how we want to help IoT to be where it should be, to be as successful as we envision it with Carl on where this market should be.
Very good. And then just very last question. How much does one of those development boards cost so that they can get that and start playing and applying your rules?
So we are in the typical range of an evaluation kit between 100 150 bucks. Let's say it's available in Arrow, DigiKey, one of our partners will be there, and you will get support, of course, to ensure that if you have any questions, there is a community around these products which is available.
Good. Or much better than that, you go to the ipXchange.tech website and fill out a form, and we send the form off to Xavier, and he helps you get hold of one of those boards, which is obviously the way that you'll go. So, Xavier, fantastic conversation this morning. Thank you very much. I've learned lots and lots about the discipline needed to take our community out of the 80% failure rate. You've given a fantastic framework to which they can apply. I implore anybody who's starting a project, who thinks they've got a project that can change the world, to maybe, first of all, for definite, go through those steps. But secondly, get in touch with Xavier and have a chat with him because he's got 20 years of experience of seeing people through this process, so that you don't join the 80%ers, which we'll call them, because there's no need for your project to be one of those 80%ers if you follow the rules that Xavier has outlined today, or at least you've got a much higher chance. So, Xavier, thank you very, very much for your time this morning. I think it's been a really interesting discussion, and I think that we can develop that into deeper discussions with some more interviews and videos as we go along. Thank you very much.
Thanks to ipXchange. Thank you, Guy. Really happy to be with you guys and sharing a bit of my journey.